folks. This is Brian with IndianPeaksWeather.net. A quick update for tonight's weather in the Front Range foothills of Colorado in the mountain town of Nederland. And you can see right now current conditions 25 degrees. Winds are from the northwest at 10 miles per hour, creating a wind chill of 15 degrees. And it's fairly moist out there right now with a dew point of 14 degrees Fahrenheit. And that combined with the temperature is producing a humidity of about 62%. And we had some weather excitement over the past 24 hours here in Nederland, Colorado. We had been watching a pretty big storm system that had dug out into the southwestern U.S. and produced some pretty substantial snowfall across the southwestern portions of Colorado. And as the storm system lifted up northeastward across Colorado, it brought with it some precipitation to the central Rockies and to the Colorado Front Range and the plains, especially in northeastern Colorado. Taking a look at CoCoRaHS. Now, if you're not familiar with CoCoRaHS, it is a citizen science network, completely volunteer, and as I always like to say, all you need is a rain gauge and a dream to participate in CoCoRaHS. And I'm a member. In fact, this is my station right down here. And all you do is once a day, usually around 6 or 7 in the morning, you report the amount of precipitation that occurred at your house or wherever your observation site is. And you report liquid, the amount of rainfall or melted snowfall, and you also record the amount of new snowfall over the past 24 hours as well as the depth of snow on the ground. And obviously during the warm season, snow is not an issue. You're just reporting liquid precipitation. And this is a map of some of the observations from the volunteer observers across Boulder County. Give you some bearing. This is Nederland right here, where Barker Reservoir is. We're a little bit, about 4 miles to the east of Nederland, here at our site, right above Boulder Canyon. And this is where Magnolia Road is down this area. Heading a little bit further north, this is Jamestown. This is Route 7 and the St. Vrain Canyon, Lyons, the city of Boulder, Colorado, and then you head out towards Longmont and Erie on the plains. And one thing you can see right away from looking at this is that the precipitation was fairly evenly distributed, but there were some pockets of heavier rain, and that's because there was convection last night. In fact, we had thunder snows here in Nederland around 10 p.m. last night. And the interesting thing about thunder snow is it's convective. And a lot of times you get graupel, and last night was no exception. And graupel is like a pellet form of snow. It always reminds me of those styrofoam pellets that sometimes things are packaged in when they're shipped or wrapped and stored in. So it's not exactly hail, although it's formed in a fairly similar way to hail, but it's soft. You can think of it almost as a soft hail. It bounces. And it counts as snow. And last night we had probably about a half-hour period where we had some very heavy graupel. Now obviously graupel is not going to accumulate quite as well as snow does, so you're going to have a lower liquid to depth ratio, and that was the case last night. But at the same time, it makes quite a bit of a racket on the roof of the house and on the deck and on our skylights of our house as well. But again, it's not hail, although it forms in a similar process to hail. And whenever you have graupel, you can be pretty certain that you have some type of convective weather situation. And that can be good to know if you're skiing up in the mountains of Colorado and starts to graupel, because if there's convection, then there's the possibility of thunder, lightning, and you may not want to be on the ski slopes during that. So that's one of those little weather-wise tidbits, especially for those who frequent the great outdoors in Colorado, and I've seen it graupel on some of the higher peaks in Colorado in the middle of the summer. But anyway, you can see that these are liquid precipitation amounts, and they range anywhere from a quarter inch, and out in the plains here where there were some thunderstorms and some heavier rain, you can see there were precipitation amounts up to 3/4 of an inch. Precipitation was mostly rain on the plains It did turn to snow for a little while early this morning, but just enough in a few places to put a light coating on grassy surfaces and cars. A little bit of a different story up here in the foothills where we're about 3,000 feet higher. When the atmosphere is moist, like it was last night, and you have some weak upslope flow or winds coming from the east, the standard lapse rate, and that's the amount the temperature decreases as you climb up into the foothills, is about 3 degrees per thousand feet, maybe 2.5 degrees per thousand feet. And then on a day where it's dry and the winds are from the west and we're getting these downslope winds off the Continental Divide, lapse rates can be 5 or 6 degrees per thousand feet. So it's definitely cooler. It usually gets cooler as you climb up into the mountains. And it was cooler up here, and it was cold enough to be mostly snow here in Nederland. I'm going to map that out here. And there you go. Not a big storm by any stretch of the imagination, but it did coat the ground with 2.5, 3 inches of snow. A few places had a little bit more, especially up in Estes County, which is the next county to the north of us, where at least the eastern part of Rocky Mountain National Park is. But it's cold now, and that snow is still here, and it looks like it's going to be cold for a few days. As we start getting to November, December, we can start getting some decent snows that have a good amount of water in them still. And when it starts getting colder, those snows can stick around for quite a while. And it's actually very pretty out there right now. And I'm fascinated by how uniform these snowfall totals are through here. I mean, look at that, 2.5, 2.3, 2.4 inches. Very consistently uniform. Even further north up towards Jamestown and as you get up to Allen's Park and Ward, same thing. So very uniform. And then I was expecting to see higher amounts up here based on the model runs last night, but it didn't really turn out to be the case. So what's in store for us weather-wise? Well, as I always say, the further out we look in the forecast, the more general I think the forecast should be. And so in the 1 to 2 day range, for example, tomorrow, Friday, and Saturday, we'll be fairly specific about the weather in terms of temperatures. You have a pretty good idea where the storm systems are going to be, where they're moving. When we get out to next Monday, Tuesday, Wednesday, it's usually better to look at trends versus specifics because there's always a lot of uncertainty that far out, and this past storm was no exception. The models were showing the storm that we had last night, they were showing it a week out, but there was all kinds of uncertainty, and each day the model solutions were a little bit different. Then once we got within a day or two of the event, I was feeling pretty confident that we would see some precipitation. We actually had a winter weather advisory up last night for 4 to 8 inches of snow, but that did not materialize. It doesn't surprise me though. It was not a really good setup for the Front Range foothills for a heavy snowfall. What I usually like to do, and I think we'll start that tonight, is go to the Climate Prediction Center and just take a quick look at the 6 to 10 day outlook and the 8 to 14 outlook. Just to get an idea what the trends are going to be in the next week or so. 6 to 10 day outlook, which takes us into next week. We're in a pattern right now. If you've been following along with my discussions over the past week, we've been seeing above normal temperatures in the east and below normal temperatures in the west. And that continues into next week at least. It's a great pattern. You have the cold temperatures in place. That means the ski areas can at least make snow. And it looks like they'll be getting some more natural snow as well. And the 8 to 14 day outlook, bring that up here. Again, pretty much the same story. Very warm, especially up in the Midwest and the Great Lakes, and still at least normal or slightly below normal temperatures expected in the west. This is a different look at it's a different way of looking at the 8 to 14 day outlook here. This is the 500 millibar outlook. And again, the 500 millibar level is about 16 to 18,000 feet above sea level. Again, that's higher than the 14ers in Colorado. And meteorologists tend to like to look at this level for a number of reasons. Again, speaking in some meteorological geekies, it's known as the level of non-divergence. Okay, well, forget I even said that. But I just thought I'd throw it out there because that's what we call it. But in less technical terms, it's a good place to look at in the atmosphere, about midway up between the surface and the tropopause. And it gives us an indication of what the winds are like, what the storms, how the storms are going to be tracking, and where the storms are, and where the areas of calm weather or ridges are as well. This particular image is a 8 to 14 day 500 millibar outlook. And what you're looking at here are the green lines are the average height for this time of year. That's the climatological height. That's if you were to go year to year, this time of year, early November, average out how high up that 500 millibar surface is, this is the picture that you would get with these green lines in here. Maybe I can zoom in a little bit. That's actually better, isn't it? So, talk about these green lines right here, and it's really not very spectacular. You do see the lowest heights are up towards the North Pole, and that's actually the polar vortex. The polar vortex made the news quite a bit a couple of years ago, especially in the Midwest and the East. And the reason that it made news is because it's often associated with colder temperatures. And you might be saying, well, Brian, what do you mean by that? Well, think about it. As the heights increase here, the 500 millibar surface, temperatures are increasing too. A column of air that is warm tends to be less dense and tends to occupy more space than a column of air that's colder. So the 500 millibar surface is actually closer to the Earth's surface up here because the air is colder, and that column of cold air is shorter. As we get down towards the equator, temperatures in general are warmer in the atmosphere, so that column of air is higher, and the surface of the 500 millibar it's higher, and it's quite a bit different. These are in decameters. I think this is 5100 meters up here, or 510 decameters. And down here it's 582 decameters, or 5,820 meters. So that's a pretty significant difference. There are a set of equations that we study when we go to weather school, and they're called the geostrophic equations. And what they basically tell us is you're looking at 500 millibars and look at the height surfaces. In the northern hemisphere, the winds tend to blow parallel to those height surfaces. I'm trying to draw an arrow here. With the lower heights on the left and the higher heights on the right. And that's called geostrophic balance. So anywhere you see these green lines, you can just picture the winds blowing between them. Now, there are exceptions to that, and that's actually a big part of why we get weather. It turns out that when these winds don't blow exactly parallel to these height contours at 500 millibars, then you can get sources of lift in the atmosphere that produce precipitation. So you can imagine that in the case here, especially around the bases of the trough, you might get some ageostrophic wind circulations. And that just means the winds aren't blowing perfectly parallel to the height contours. Okay. On a more practical level, though, it's just good to remember that the lower heights typically correspond to colder temperatures, and the higher heights, which you see down here, typically correspond to higher temperatures. And I'll say H and L there. All right. So what really sticks out right here? Well, you might notice there's some other dashed lines that are underneath these contour lines. And that's showing in the 8 to 14 day period, this is where we'll have height anomalies, or this is where we're expecting height anomalies. So the green contours are the normal heights, and this area, New Brunswick, Nova Scotia, and New England, we're looking at a pretty good probability of above normal heights. And this value shows you just how much those heights will be above normal. So that will translate into a good possibility that there's going to be a ridge here in warmer temperatures. And if you think about the 8 to 14 day outlook we just saw, we're looking at some much above normal temperatures in the northeastern U.S. Conversely, over towards Alaska, look at this. These blue dashed lines are saying that the heights are expected to be 20 to 60 decameters below normal. So temperatures should be colder than normal here, and we'd expect there to be like an upper level trough in this area. It's good to look at these climate charts because it does give you a broad brush idea of where it's going to be warm and cold, but where storminess will be possible. Generally in the warm areas, it'll be fair, and in the cooler areas where the heights are more below normal, I should say, there's a better chance of storminess. All right, well, that's probably enough of that for now. So let's dive into the models. All right, we'll go back, and I'm going to look at the NAM right now, the short range model. And we'll try to get back to the beginning here. And here we go. So this is, I'm going to start off at 500 millibars again, because I like to do that. And it gives us a really good idea of what's going on and what's coming our way. So this is the initialization. This was this evening. And this is the storm system here that brought us the snow and the precipitation. It's a trough here. It's basically ejecting out this way. As we loop through it, you'll just keep an eye on that. As we loop through that, you'll see that this trough will eject, and it'll get weaker as it goes over the top of this ridge. It's really cool to look at the waves in the mid-levels of the atmosphere. And when I say waves, you can see them here. There's a ridge here. It's like a wave. There's a ridge over here, over the eastern U.S. Again, ridges tend to be accompanied by warmer temperatures. That's why we're seeing the warmer temperatures in the east right now. Troughs, and this is a trough here. Marking some axes here. You can see the trough. There you go. Tend to be associated with cooler temperatures and increased chances of precipitation and storminess. So let's just step forward a few frames here so you can see how these features evolve. Make it bigger too. There goes that trough. And look how quickly it ejects out of here. It rides over the top of the ridge. And as it goes over the top of the ridge, it weakens considerably. Over us, though, we're in a long wavelength trough right now. And you notice that some moisture pushes over us tomorrow, at least at 500 millibars. It doesn't look like there's much lift associated with this, though, so I wouldn't expect anything in the way of precipitation, but there'll definitely be some clouds around. And then as we step forward into later in the day on Friday, you can watch these features as they progress. Saturday morning, look what we have on our doorstep. This trough is finally exiting to our east, and we have this nice ridge here. This would tell me, looking at this map, that I'd expect there to be warm air advection moving into Colorado and the Rockies and even into the plains as this trough, as this ridge of high pressure in the mid-levels of the atmosphere pushes into us. Let's see what happens here as we get a little bit further into Saturday. And there you go. By Saturday evening, we're pretty much square under that ridge. Not a very strong ridge, but ridges tend to be associated with warmer temperature and fairer weather. Typically, there are always exceptions, but it's a good rule of thumb to remember. Meanwhile, off the west coast here, Pacific Northwest, in California, look what we have coming in there. I'll mark this trough axis here. And as I said the past few times, when you go to weather school, you learn that the best source of lift tends to be to the east of the trough axis. So here's a trough here too. There tends to be more lift here. There tends to be descending air here. I feel like we're watching a football game here. So you tend to have more weather on the east side of the trough, increased chances of precipitation, and then fairer weather as the trough exits and you get to the west side of the trough axis. Just I'll always bring that up because you can learn a lot from these big features in the atmosphere, and then you work your way down to lower levels of the atmosphere, figuring out if there's moisture available for that lift. If so, how much moisture is available? How fast are these features moving? How much precipitation may occur from them? Always looking for sources of lift, and that's what we're doing here. But us being under a ridge axis on Saturday evening, very little lift there. In fact, Saturday should be a superb day. We've been having some amazing weekends here in Colorado this fall, and it looks like this weekend will be no exception. Keep going. Sunday, watch that trough as it digs into the west coast there. And I say it's digging because you can just imagine it as we're stepping along here. It's digging south and east. See that? It's a non-technical term, but you'll hear it a lot. And this is the last frame of the North American model. It's 84 hours out, which takes us to Monday morning, and leaves us perched in a situation not unlike this past storm that we had, somewhat analogous, although the models are differing on what's going to happen with this trough here. The European model wants to take it down here by Tuesday and Wednesday and cut it off, basically. That'd be great for us for precipitation and snow, especially in the Front Range foothills along the Continental Divide. But the GFS, which is the American model, wants to keep this wave open and take it more or less toward north, which would leave us high and dry pretty much here on the Front Range in terms of precipitation. Either way, I would expect to see colder temperatures coming in with this trough as it advects towards us, whether it goes to our south and cuts off or it goes to our north and just exits as an open wave. We'll see. That's a long ways off still. That's 4 or 5 days off. A lot can change in the forecast. But I guess the main point I want you to take away from this tonight is that it's going to be cool, fairly cool, the next couple of days, especially tomorrow. Our high today, I think, was 34 degrees, and I think the highs tomorrow may get up into the 40s. In fact, let's take a look at the Weather Underground forecast, and we can critique it. This, that, and there we go. Forecast for Netherlands. All right. There you are. So yeah, look at this. According to this forecast, Friday's highs will be in the upper 20s. I'm thinking we'll probably get into the low 30s. And lows tonight, pretty chilly. Coldest weather of the season. I repeat, definitely the coldest weather we've seen so far this year. And we're looking at lows tomorrow night down in the teens. Saturday, pretty chilly in the foothills. You go down into the plains though, it could be a decent day with highs getting up to the low to mid 50s. Sunday looks really nice. 44 degrees here in Netherlands in November. That's shirts and short sleeves weather. That's when they get the little league out to play baseball. Now in the plains, that means temperatures being generally 15 degrees warmer or so, probably in the upper 50s, low 60s. So not a bad weekend at all. Still warm enough to get out and run and hike in the lower elevations, and even maybe bike a little bit. And then the big question mark, which I'll talk more about over the next couple of days when we have more data. I've been watching the Weather Underground forecast, and it's been bouncing back and forth between, oh, well, in this case, 6 to 11 inches of snow and, well, hardly anything. And it's because there's some big differences between the GFS and the European model as to where that next trough is going to track. It's all in how the trough tracks. If it moves to our south and cuts off, we'll get more easterly flow and more upslope flow, and that's what we need here in the Front Range to get a good snow event. It's a deep layer of easterly winds plenty of moisture blowing up the continental divide. So we'll see what happens. But anyway, I appreciate your spending an evening here with me, at least a few minutes of your evening here with me, and we'll talk some more in the next couple days. Did want to just show you one more thing though, now I think about it. I want you to get used to looking at these soundings. And briefly, we talked about this last time. This is showing the winds as you increase in height in the atmosphere. And you can see the heights over here, 5,000, 10,000, 14,000, 19,000, 24,000, so on and so forth. Here's the 500 millibar level we've been talking about 19,000 feet there. So we're looking at the atmosphere from a bottom-up perspective. The surface is down here, and if you were to get into an airplane, you can fly up and up, up and up to 35,000 feet. This gives you a pretty good idea as you're in that aircraft, or if you're climbing a 14er, what the temperature is going to do as you climb, as you go up in height. The solid line is temperature. This dashed line is dew point. And as I was telling you last time, where these two lines are farther apart, like here, that's where the atmosphere is drier, and where they're closer together, the atmosphere is moister. Not a lot of moisture in the atmosphere this evening. This is a really cool feature right here. This little kink in the temperature. Basically, the temperatures are decreasing until you get to this point, and then they become what we call basically isothermal above that. And that is the tropopause. Above that is the stratosphere. Below that is the troposphere. Troposphere is important because most of our weather occurs in the troposphere. Most of our weather occurs down here where there's instability and there's plenty of moisture. Stratosphere is very stable. And again, as you can see, the temperatures barely change much. So any weather that happens in the troposphere tends not to get too far into the stratosphere. But anyway, I thought that was interesting to look at, and you can see right now the winds are generally from the west throughout the whole, all the way up to the tropopause. They're actually up to about 75 miles per hour as you get closer to tropopause, but much lighter down here towards the surface. So the atmosphere is dry. We probably have some sinking motion here. That's probably what this is you're seeing here, some subsidence we call it in weatherese speak. Sinking air tends to inhibit cloud growth and precipitation growth, and so you tend to get clear skies, and things are pretty clear outside right now. All right, well, thanks again, and I'll post either tomorrow or Saturday, and we'll talk about next week's potential storm.